Hello everyone, we're going to be talking about applications of rational expressions, section 6.5. So we've kind of talked about rational expressions and how they are in the abstract sense. Now we're going to see kind of how they are applied to real world situations and how they're used in word problems. This first example, and we're just going to go ahead and jump right into the examples. In physics, the focal length f of a lens is given by, and it says 1 over f equals 1 over p plus 1 over q, where p equals the distance from the lens to the object and q is the distance from lens to the image. So we have a diagram here that shows the image, which is the screen, distance to the lens, and then the focal length is the image or the screen to the focal point of the lens and the camera and how it operates, and then p is the distance to the object from the lens. Okay, so we have a big equation here of kind of putting all this information together. So we're going to go ahead and put in the information that we know. So for f, we're going to go ahead and put in 10. For p, we're going to go ahead and put in 20. And we are trying to find the distance of from the lens to the image. So we're going to put 1 over q and we're going to leave it. The only thing we need to do is we need to solve for q. So we need to multiply both sides of the equation by something that will eliminate all the denominators, okay? Now we can multiply them all together, 10 times 20 times q, and we can get 200q, and you wouldn't be wrong, but you would get a number that's too big, and you'd have to reduce it when you're done. So it's not a terrible thing, but we can find a more efficient way to do it. So what is something that 10, 20, and q all go into? That is 20q. 20 will cancel with 10, 20q will cancel with the 20, and 20q will cancel with the q. Now I'm going to rewrite this, and I'm extending the numerator so that you show that we're multiplying each term by the top, which is 20q. So now we're going to write times 20q, times 20q, times 20q, because what we're doing is we are distributing to all three terms. Okay? All right. So now we have some stuff we can cancel. So we can cancel the 10 with the 20, and we're left with 2. We cancel the 20 with the 20, and we can cancel the q with the q. What's left? Well, we have 2 times 1, which is 2, q, equals 1q, or just q, plus 1 times 20, 20. We subtract q from both sides, and we get q equals 20. Let's put it in the context of the problem. We're talking about centimeters, and that's the length of the image to the lens. So that's our answer. Now we have a more abstract sense. We're trying to solve for p. So if we wanted to find the distance from the lens to the object and just want to input variables or numbers for our variables, we would go ahead and do that. So now we have a problem where we want to get rid of all the denominators, but now there's no numbers. So we need to find our least common multiple. What do f, p, and q all go into? In this case, we are going to multiply all three together, and that is our least common multiple. There's nothing else that f, p, and q all go into except for f times p times q. Now we do the same thing. So we have 1 over f equals 1 over p plus 1 over q. And again, we're doing the same process, which is distributing to all three terms. So times f, p, q, or f times p times q, it's the same thing, f, p, q, f, p, q. What can we cancel? Well, we can cancel the f with the f, the p with the p, and the q with the q. What's left? pq times 1, which is just that, fq plus fp. We have a problem. We're trying to solve for p, and p is in multiple locations. So let's get all the p's together. So I want to subtract both sides by fp so I can get the p's together. fq, I'm going to leave him alone on the right side because he doesn't have a p in him. So I have pq minus fp equals fq. P is still not alone. P's here, p's here. I can factor him out. Take a look. Factor out the p. What's left in the parentheses? Q minus f. And that equals fq. It's still not alone, so I'm going to divide both sides by q minus f. Once I do that, it crosses off, and we're left with our final answer. our final answer being P equals FQ divided by Q minus F. So this was kind of like a quick intro on how to do these types of problems. We are going to get into more complex examples soon, so stay tuned for after example 2.